start. Happy day, everybody. This is Orekoya Olusegun, Physics Mathematics Fundamentals on YouTube. Please, before we go into today's work, do not forget to like, share, subscribe, and click on the bell button to have more of my video. Thank you. Today, we are taking a topic in mathematics, and that topic is on application of a trapezoidal rule in estimating the value of a given definite integral. What do I mean by that is this. If you look at this particular integral, let's say we have a to b, then we have function of x with respect to variable x. Each of these are called the limits. Anytime you are given the limit, we are dealing with what is called definite integral. If you have similar things written like this, and then the limits are not given, we call it indefinite integral. An example of definite integral is what you have, let's say from the limit 0 to 2 of x squared with respect to the x. This is an example of definite integral. When you have the same thing written without the limit given, this is an example of indefinite integral. Now, how do we work on an integration? Let's say we have x raised to power n with respect to variable x. To integrate this, what we normally do is to add 1 to the power and divide whatever we get with it. So for the indefinite integral, you add your constant of integration. This is for indefinite integral. Indefinite integral. So if you want to integrate definite integral, you are given the limits. In this case, let's say we have a x raised to power n dx. Like I said the other time, for this, add 1 to this power. So you are going to have a x raised to power n plus 1. Let's say the limits. I'm giving the limit as x1 to x2. So divided by whatever you had when you add 1 to the power. So in this case, you are not going to write the constants of integration. You are not going to write it. So you put the limit. You put the limit closer. So you have x1, then x2 there. So what you are going to do is to substitute this limit here. So you are going to have ax subscript 2 plus n plus 1 divided by n plus 1. You now say minus, you substitute the lower limit into x there. That is ax raised by n plus 1 divided by n plus 1. So this is how to obtain the integration when the limits are given. Another way to do this work quickly is to take this constant n plus 1 outside the integration expression here. So you can have it as 1 over n plus 1. Then you have ax raised by n plus 1. Then you put your limit x1 to x2. Then before you now substitute and subtract, you are still going to get the same thing. Now, if you want to now apply trapezoidal rule in finding the value for integration in which the limits are given, before we do that, recall that when we have a trapezium of this format, these are parallel sides. Let's call this one A, and this side call it B, and the distance, the vertical distance between them, call it H. The area A of this trapezium is given as half A, the sum of the parallel side A plus B, then times the distance between the parallel sides. That's the fundamental idea concerning that. Now, if the question says estimate this particular integral, we are given the limit 0 to 2, and we are asked to take a number of stripes to be 4 stripes. I'll tell us what I mean by 4 stripes. 4 stripes simply means 4 trapezia. Trapezia. 4 trapezia. So what this one means is this. If you have the function f of x with respect to variable x, let's have an arbitrary call for that function. Now, 4th trapezium simply means you have, this is number 1 trapezium, this is the first trapezium, this will be the second trapezium, this will be the third trapezium, and this will be the fourth trapezium. That is a subscript 4. So here will be your x1, this will be your x2, This will be your x3, x4, x5. And this vertical line will be your y1. This vertical line will be your y2. This vertical line will be your y3. This vertical line will be your y4. And this vertical line will be your y5. So the limit is from 0 to 2. So that means this, my x1 is 0. And the last value for x here is 2. Since we are told to use 4 stripes, what we are going to do is to find the value for the interval along this x-axis. And that interval, the value for that interval is the range of the limit. Range of the limit divided by number of stripes. And the range of the limit simply means upper minus lower. 2 minus 0 divided by number of stripes, that divided by 4. So I have 2 divided by 4. 4 in 2, 0 points. 4 in 20, that will be 0.5. Now, in this case now, I'm going to, this particular integral is actually means summation of all the area under the curve. So this total area here is actually the integral we want to find, and is given as a1 plus a2 plus a3 plus a4. Now if you look at this first trapezium, the area a1 is actually mean half, then the sum of the parallel side, that is y1 plus y2, half y1 plus y2 divided by the distance between this parallel line, that is x2 minus x1, that is times, not divided, please, is times. That is for a1. Then for the a2 is going to be half the trapezium, sum of the parallel side, that is a y2 plus y3, then times the difference between the parallel side, that is x3 minus x2. Then for the a3, the area a3 is going to be half brackets sum of the parallel side, that is a y3 plus y4 times the difference, that is x4 minus x3. Then the last one, which is a4, is going to be half, then it's going to be different between the parallel side, that is y5 plus y4 times the difference here, that is x5 minus x4. So when we add all this together, we are going to find the value of the integration. Now I'm going to have, because the relationship between x and the function y is equal to x squared. So I'm going to have what is called a table of value. I'm going to have my counter here. You know, my x stands for x1 up to 5. So my counter will be 1, 2, 3, 4, 5. Then I'll write xi. Then I'll write yi. Yi is equal to, according to this function, is xi squared. So now, what do we do? If you look at my relationship here, because the interval given here, the range divided by the number of stripes, this is 0.5. If I'm starting with I'm going to start this place with 0. The next one will be 0 plus this 0.5 that I have here. So the first one will be 0, then plus this 0.5 will give us the x2 when our counter is 2. So it's going to be 0.5. Then we add 0.5 again, that will be 1.0. We have 0.5, I have 1.5. Then we have 0.5, that's going to be 2.0. You can see that we have covered from the lower limit to the upper limit, which is what I have here, 0 to 2. So the next thing is that we should square it according to the function inside the integral sign, that we should square it. So we are going to be squaring each of these. So it's going to be 0 squared. 0 squared will give us 0. Then it's going to be, when x is 0.5, we put it here. So we write 0.5 squared, and that gives us a, sorry, let me demarcate so that we can easily see what is happening. Sorry about that. So when x is 0.5, when we square it, we are going to have 0.25. When x is 1, when we square it, it's going to be 1.00. Let me put it then to the two decimal places. So when x is 1.5, we square it, 1.5 squared. So we are having 2.25. When x is 5, when x is 2, we put 2 here. 2 square will give us 4.00. So now we are now going to substitute each of these values inside what we have here. We know that the difference between each of these is 0.5. So all these differences I have here is just 0.5. So my a1 is going to be 1 over 2 bracket y1 plus y2. That is, my y1 is 0, my y2 is this. So it's going to be 0.25 plus 0. Then times 0.5. The reason is this. The difference between this interval is this 0.5. So from here to here is 0.5. From here to here, so I'm just going to be putting 0.5 for whatever parameter I have on this side. So that we'll get an answer later for that. Then for a2 is going to be half bracket y2 plus y3. This is a y2, that's a 0.25 plus y3. This is y3, that's plus 1, then times 0.5. We're going to have an answer for that. For a3, it's going to be half. It's going to be half times y3 plus y4. This is y3 plus y4. That is 1.00 plus y4 is a 2.25. Then times 0.5. We're going to have an answer to that. Then a4 is going to be half bracket. According to a4, I have a 1.5. That is y5. That is 4 plus y4 is 2.25. 2.25. Then times 0.5. So pressing the calculator, I'm going to have 0.0625. Then this next one, half times 0.25 plus this, I'm going to have 0.3125. For the next one here, I'm going to have 0.8125. Then for the last one, I'm going to have 1.5625. Those are the areas. So total areas will be the addition of all that I've obtained so far. So the total area now is going to be addition of everything I have here. So 80 now, which is the integral we are looking for, is to add all these values for a1 plus a2 plus a3 plus a4. So when I add them together, I have roughly 2.75. That's my final answer for that. If you recall, when I integrate this one using this particular formula originally, I have x squared dx. When I did the normal integration, what I got as my answer is 2.67. You can see that using the trapezoidal method, I have 2.75. Using the direct integration method, I have 2.67. So what I have here is just an approximate to the actual value. Now, for this value to be closer to the actual value, I can increase the number of strides. I can make my strides to be maybe 10, to be 20, to be 40, and things, and so on and so forth. You discover that the value that I'm going to be having when I add all the stripes, the area of the stripes of the trapezoid together, will be close to the actual value. Thank you so much. I believe that you must have learned one or two things on this presentation. Please do not forget to like, share, subscribe, and click on the button to have more of my video. Have a nice day. Bye.